Boys and girls, it's Noah time! Noah time!
1. I'm going to start off by going back to elementary school, grade 6. In grade 6, you learn something called area. It's going to say, find the area of this, and this was 3 cm, maybe this is 1 cm, and then your teacher says, find area. Very, very simple. And most of you went, well, that's easy. That's 3 times 1, which is 3 cm squared. So that's easy because it's just a simple box. In calculus, I'm not here to do things that are simple. I want to do things that are a bit more tricky. If I give you this, y equals to x squared, and I'm going to say, find the area under the curve from 0 to 4. It says find the area under the curve from 0 to 4. First thing I want to do is I want to visualize what this looks like. So draw my parabola. My parabola is an x squared, so it looks something like that. Very, very simple. Actually, I should draw a better one. This looks pretty bad. There's my parabola right there. Maybe this is 0. And I'm going to say this is 4 somewhere here. I'm playing the guessing game. I don't know where it is. And what the question is really asking you is, find this area right here. Find the area under the curve from 0 to 4. So if I were to look for this one, question is, how do you do it? I'm going to pause it and let you come up with some. There's many ways to do it. If I look at this, I can play the guessing game. I can think of this, and I can guess, say, well, if I look at this, it looks like one big rectangle right here. So let's draw one big rectangle. There's my one big rectangle right here. So what I can do is, I know the base of this rectangle is 4 from here to here. I know the height. Find the height for me, please, of this rectangle right here. Go. You need to know the height of a rectangle. What is it? Infinity. No, there's actually a number to this. There's the actual answer to this. Come on. 16 is correct. Because I subbed in 4. Because when I sub in 4, that becomes 4 squared, so that's 16. So my answer really is 16 times 4, which gives me 24. Problem is, whoa, not 24, 64. It's 64. Problem with this is an overestimation. The reason why it's an overestimation is because the area of this big rectangle includes everything that's also above the curve. So that didn't work out too well. So let's try another one. But if I take this one same concept and I do something unique to it, watch what I'm going to do to this one. We're going to do a lot of drawings today because it's going to be and I'm going to introduce a lot of weird vocabs and symbols in math today. If I take that one concept and I say, what if now, instead of breaking into one big rectangle, why don't I break it up into maybe 4 rectangles? Because really, when I break them into 4 rectangles, it may be slightly more accurate. So let's draw 4 pieces for now. 1, 2, 1, 2, 3, 4. And let's assume these are all the same. We're going to draw. So now I decide to break them into 4 pieces. We'll call this 1, 2, 3, and 4. I'm going to draw in my rectangles right here. So draw it in. See? So instead of breaking them into 1, I decided to break up into 4 pieces. Because 4 maybe give me a more better accurate answer than 1. If I look at this one, I can create rectangles. Watch, here's where it gets a bit tricky. I'm going to put a dot here, dot here, dot here, and dot here. 4 dots. I'm going to use these dots to create little rectangles. There's one here, there's one here, there's one here, and there's one here. Okay. Notice one thing, I'm using the right end points to create these rectangles. That's what I'm doing. I'm using the right end points. Now, problem is, so let's go ahead, I want you to find the area of this using the right endpoints. So find the area of the first rectangle, second rectangle, third rectangle, and fourth rectangle. I'm going to pause it. I need a bit of help. I'm going to start you off with the first rectangle. Here's my first rectangle right here. I'll highlight it for you. This one right here. Well, the base of that really is, we'll call this rectangle 1, which is 1 times 1, which gives me 1. That's it. Let's look at the next one, rectangle 2. Well, rectangle 2, the base is still just 1, but the height is now 4, so which is 4. Go ahead and do the next one for me, please. Rectangle 3, rectangle 4. So I can do 1 times 9, which is 9. And this is 1 times 16, which is 16. So now I add all this together, and I can get the total is 25, 29, 30. See, notice 30 is actually a better answer than 64. But the problem is this. This is, now the question is, I'm not going to ask, Karanveer, is this an overestimation or an underestimation?
Seems like a bit over.
Seems like a bit over because there's extra pieces here. So the right approach gives you an overestimation. So we're going to write this down. Overestimation. Because the right-handed approach gives you something that is over. We're going to do this again. This time, I want you to do from the left-hand approach. I'm going to show you how to do the left-hand approach this time. So we're going to draw the same curve. So what I'm going to do is I go 0, and we're going to break up into 4 pieces again. 1, 2, 3, 4. Okay. So I want you to draw in your rectangle this time. But this time, you're going to use the left points. Put a dot. 1. See, I'm starting at 0. I'm using the left end points. 2. 3. And I'm using the third one. Because when I'm using it from the left side, I'm using 0, not 1 anymore. So now here's my rectangle. The first one is really nothing because you can't see it. But the second one is right here. See? Right there. And I don't go any more than that. Oops, sorry, I do one more. There's my last one right here. So really in this one, there's my rectangles. 1, 2, 3, and fourth one, which is a 0. This is called left endpoint approach. On the exam, they're going to specify which endpoint approach they want, and you have to be able to calculate it based on how many intervals they want. Find the area of the left endpoint approach. Go. I'll pause it. The first one should just be, so we'll call this rectangle 1, which is 0 times 0. Well, simply that's 0. Rectangle 2. That's 1 times 1. That's 1. Rectangle 3. That's 2 times 4. Sorry? How's it 2 for which one? Oh, sorry, no, that was the wrong one. I was looking at the next one. That should be 1 times 4, which is 4. And finally, the fourth rectangle is just 1 times 9. Gives you 9. In total, that's 13, that's 14. So this is if I look at this, there's still some pieces missing. So we call this an underestimation. This is an underestimation. So I know that my areas will be somewhere between 14 and 30. What's the right area? I don't know yet. Case 3. I can do the right endpoint. I can do left endpoints. There's one more endpoint which I haven't figured out yet. There's 3 scenarios where you can actually calculate this from. Draw, break up to 4 pieces again. 0, 1, 2, 3, 4. The question now lies in, what is the third case going to be? You have the left endpoint, you have the right endpoint. There's one more case we didn't calculate yet. And figure it out? Wait, what is it, Soraya? The middle, that's correct. So I'm going to go in the middle, somewhere between here, put a dot. So the third case is called the midpoint case. Put a dot in the middle, put a dot in the middle, and put a dot in the middle. We're going to use these values, and we're going to draw your line, your bar graph. See? I'm using the middle value now. So this is called the midpoint approach. Midpoint. Calculate the midpoint. I'll give you a few minutes slowly. So this is going to be a rectangle 1. Well, rectangle 1 equals to 1 times, now you got to be careful, I'm using 0.5 squared. Because halfway between 0 and 1 is 0.5. Punch it on your calculator and you get your answer, whatever that is. Jasmine, what was the answer? Did you get the answer for rectangle 1 yet? Sorry? 0.25. So there's my first one. Guys, finish it up. So you can actually do the next one on your own. Rectangle 2, which is 1, times, now I'm halfway between 1 and 2, so that gives you 1.5 squared. Rectangle 3, 1 times 2.5 squared. And rectangle 4, 1 times 3.5 squared. Sorry? How are you getting there? Because I want the midpoint between each region, right? So the midpoint here is 0.5. Midpoint here is 1.5, 2.5, and 3.5. These midpoint is what I'm going to use in my calculation, and you can actually punch it in, and you get the answer, whatever that is. Pragya, you have an answer? Yeah. Well, what's your answer? Total, yep. 21? So my total here is 21. So which is the right answer? The left, right, or middle? We don't know yet. Because here, I took only 4 rectangles. Would you agree, if I decided to take 10 rectangles, it would be even more accurate? On the test, guess how many rectangles you're going to use? 100.
Oh, I was right.
You're going to use Because why? The more we do, but we don't have time to take 100. So we call that the limit as the number of rectangle approaches infinity. Because if I take infinite amount of rectangles, I actually get the perfect curve. And that's what that's what this builds on. I want to give you this question. Try it on your own, please. I'm going to walk around and help you out. F of x equals to 1 over x. Find the area. Under the curve. From 0, actually, from 0, no, actually from 1 to 3. Using four rectangles, and you are going to do right endpoints. You're going to use the right endpoints. Sketch the diagram of what it looks like. This is a typical exam question. I'm going to pause it. So I'm going to start off with just a basic diagram. My graph, I'm just going to focus on this. When I walked around, I saw a lot of you had something like this. Okay. I'm going to leave some room to just show you what it looks like. From 1 to 3, and there's going to be 4 rectangles. Yeah, we don't need to worry about it because I want only from 1 to 3. Okay? So now I have to divide that into 4 rectangles before I reach 3. I don't know what they are yet. 1, 2, 3, and here's 3. Because there's my 4 rectangles right there. I'm not going to draw in the rectangles, not yet. Now, go ahead and label what each one of these are. Because you need to label that before you can do this. Without that, you can't do it. Okay. Question is, how do you do this next one? Sylvia, how do you know what these are? But the question is, it's correct, but how did you get that? There's actually a formula you got to figure out. You're close. 3 has something with 3 first. 3 minus 1. You take this, divide by this. Sorry, subtract this. But then you divide it by 4. Because there's 4 rectangles. So I want to know what is the distance of each one. That works out to be 0.5. And that's why this is 1.5, 2, and 2.5. Put a bubble around this formula. You're going to need to know this. This is also known as delta x. Delta x means what's the length of the base. So I'm going to start using marking terms that you know. So this is known as delta x. Notice I want right endpoints. So right endpoints means I'm going to choose from the right side of each rectangle. I'm going to put a dot at 1.5. I'm going to put a dot at 2, 2.5, and 3. Create my 4 rectangles and find the area of each one for me. Go. So what I'm going to do, I'm going to create my rectangle. There's my rectangle. There's my rectangle. There's my rectangle. And there's my rectangle right there. There's 4 rectangles. I'm going to find the area of each rectangle right now. Rectangle 1 equals to blank times blank. So nothing too bad. Keep it simple. 0.5 is correct. Nope, because we're using a different formula now. So it'll be times 1 over 0.5. Because I'm using a different formula. Which, if my math is correct, you should have 1. Guys, sorry, Manat, I was listening to Manat. That should be 1.5. Manat, I blame it on you. That should be 1.5. I was walking around like, wait a minute, Manat, you're wrong. So whoever's listening to this recording, that's Manat, M-A-N-A-T. Isn't that how you spell your name? No? Oh. So that way I can't pinpoint. So when you say, Mr. you blame on me, I didn't blame on you. I blame on a different Manat. So that should be 1.5. I'm like, what the heck is going on? And then go ahead, punch in your calculator, grab your calculator out, whatever that is. Anyone have a calculator? Sorry? 1/3? Hey, 1/3 is what I hear. The next one. 0.5 times 1. This time, notice I'm using the number 2 this time because I'm using the right endpoint, which is 2. Which is 1/2 times, which is 1/4. Rectangle 3, which is 0.5 times 1 over 2.5. And then rectangle 4, 0.5 times 1 over 3. Punch all that in your calculator and add them together. You can use decimals if you want. $2.75 is what I hear. Sorry? 0.2? 0.95 altogether? So if I add everything all together, I'm going to quickly do it in my head, and I have 0.95. Hi. So that is the area under the curve for 4 rectangles. Easy. But the problem is, that's just too easy. That's not calculus. This is just an introduction to calculus. Here is where I'm going to introduce a bit of concepts. I'm going to introduce a new symbol for you. You're going to use this symbol a lot in university. Doot, doot, doot. Does anyone know what that symbol means in math? Oh, yeah. Wait, where have you learned this? Grade physics? Oh, thank you to Mr. Salzman. This is called sigma notation. If you're planning to go into chemistry, physics, or math, you're going to need to know this symbol. This is called sigma notation. Sigma notation means sum of. I'm going to show you how this sum of works. If I go 1 plus 2 plus 3 plus 4 plus ... 100. I don't want to write down all that because it's too tedious and boring. So I can rewrite this as sigma. We're going to write down the number I, or x. We'll call this x. Okay. When at the bottom, this tells you where you're starting from. This is your starting value. Starting. So notice I'm starting with x equals to 1. I have 1. The top is my finish, or what number I'm going to use, and I stop right there. Well, I'm going to let x be 100. So this is 100. Which means 1 plus 2 plus 3 plus 4 plus so and so up to 100. That's what it really means. I'm going to give you a sigma question. You're going to solve this for me. Sigma. I equals to 2. 5. 2i minus 6. There's your question. Solve it. Go. Plus, I'm going to give you a little hint. So what this means, this is my equation to get the first number. So this is the equation for first number. You can choose whatever you want for here for your starting. I just chose 1 before. So what I'm going to do is I'm going to sub in I equals to 2 into here. So watch what I'm going to do carefully. 2 times 2 minus 6. Well, that equals to negative 2. That's my first number right there. First number. Then I'm going to do this again to get my second number. So I go 2, but notice I'm not using 2 anymore. I'm going to go 1 up, which is 3 minus 6. I want you to go all the way up to 5 because this is your max. And then add those numbers together. Then I can go 2 times 4 minus 6. 2 times 5 minus 6 gives you 2, gives you 4. So now, sigma means sum of. So what I'm going to do, I'm going to add all these numbers up. And that should give you 4. So the answer to this is 4. That's called sigma notation. I'm going to go back to that question of yours. But this time, I'm not going to use numbers. I'm going to use pure abbreviations. Oh, and this is where it gets tricky. Actually, I'm not going to start that today because you're going to kill a lot of brain cells.